In this video, we're going to look at how we can use differentiation to solve rate of change problems. Differentiation can be used to solve problems involving rates of change, such as speed, because speed is the rate of change of distance with respect to time, so s equals dd by dt. Velocity, v, is the rate of change of displacement with respect to time, so v equals ds by dt. And acceleration, or a, is the rate of change of velocity with respect to time, so a is dv by dt. Or it can be considered as the second derivative of the displacement, so a equals d2s by dt squared. So in this example, the displacement of a particle relative to the origin is given by s equals 4t cubed minus 5t squared minus 6t plus 11, where s is the displacement in millimeters and t is the time in seconds. And firstly, we want to find its initial displacement relative to the origin. Now we know that the initial displacement is when t equals 0 because it's at the start of the particle's journey. So we want to know what happens when we substitute t equals 0 into our displacement formula. So we were looking to calculate s of 0. And so that's 4 times 0 cubed minus 5 times 0 squared minus 6 times 0 plus 11. And so the initial displacement relative to the origin is 11 millimeters. Now part B asks, what is the particle's velocity after 2 seconds? So we need to remember that velocity is the rate of change of the displacement with respect to time. So v equals ds by dt. So we need to differentiate s and work out what the value is at t equals 2, because we're asked after 2 seconds. So s is 4t cubed minus 5t squared minus 6t plus 11. So the derivative of s with respect to t is going to give us 12t squared minus 10t minus 6. And then we need to substitute in the value of 2 in place of our t, and so we get v equals 12 multiplied by 2 squared minus 10 times 2, take away 6, giving us a value of 22, and our units are millimeters per second. Now part C asks us to work out when its acceleration is 0 centimeters per squared second or millimeters per squared second, or even meters per squared second, because we want to know when the acceleration is at 0. And that's going to be when a is the rate of change of the velocity with respect to time. And so we need to work out, taking v equals 12t squared minus 10t minus 6, and differentiating that with respect to time, and that will give us a value of 24t minus 10, and we're going to make that equal to 0 so that we can work out what the time is when the acceleration is 0. So doing some rearranging, we end up with t equals 10 over 24, and we must remember to simplify that fraction to 5 over 12 seconds.